Good morning, class, and today we're going to be doing one last high-level example of problem solving that can involve both kinematics, forces, and momentum in the same time. This is one where we definitely have to summarize our problems in our own words, make an and-then statement, and then try to connect the pieces. This type of example is a really common form where there's a collision and then some sliding. And this sort of problem you should expect to see in multiple places. This is kind of the highest level problem that we're going to be doing in Physics 11 now. So let's go ahead and get comfortable with it. What we've already actually seen one of these examples in our earlier set of notes, where we had the beginning information and we had to find out how far it slid. That's the end information. The goal for this and our assignment is show that we can find information at any period in time. So this example, we're trying to find the coefficient of friction that is occurring in the slide, whereas the homework assignment that you're going to have to do for Wednesday is you're going to have to find the initial velocity of the car. However, they're all set up in the same way because they all summarize to the same statements. Let's begin by writing in our summary with that and then moment. When I read this problem, this car is traveling 20 meters per second, collides with a car at rest. They stick together and skid across the road, come to a stop 15 meters away where they collided. Determine the coefficient of friction. My summary would say the cars collided, and then the cars skidded across the road with friction. Again, color coding highlight to help me organize what I'm thinking. There we go. And the thing I want to know is the coefficient of friction. The coefficient of friction is a force problem, and that force problem is in our green section, or where it's skidding across the road. So here are our two cars stuck together, but they're stuck together, so I'm going to treat them like one object. We know that they're skidding across the road, but there's some gravity, there's some normal force, and there is some friction. Now if I looked at this, I'd say, okay, well, I know my net force will be just my friction, because in this case there are no other forces. They collided. They're not going to be stomping on the gas in this case, so they're colliding and friction is slowing them down. I would just have to take my mass multiplied by my acceleration. That's my formula for net force, and that would equal my coefficient multiplied by my normal force. The mass is good because I know they're combined together. I get to add the two masses together. 1500 and 1250 is going to be 2750. I'm not given the acceleration, and I don't have a way to solve it right now. So I'm going to leave acceleration blank. The coefficient of friction is what I'm trying to solve for. And the normal force, we can know, is balancing the gravity. And the gravity is going to be our 2750 multiplied by 9.8. So normal force here is going to balance it. So I'd be able to write that in there. Unfortunately, it looks like we can't solve for our coefficient of friction entirely yet. Even if we divided out both of the multipliers, we'd see that our coefficient of friction still relates to the acceleration that this object is feeling. So we need to find the acceleration of this object as it's slowing down. That means I'm going to have to use kinematics. So let's see what we have in our kinematics. We know it's coming to a stop. If I can find my acceleration, I can plug it back into my coefficient of friction formula, and that will help. I know that it took 15 meters to come to a stop, so that's good, and I don't know anything about time. So you might feel, oh no, we don't have enough information, but that's what the other part of our and then is. our yellow highlighted information happens before our green highlighted information. So that means the ending of our yellow situation is the beginning of our green situation. That means if I can find the final velocity when the cars collided, then that would be the initial velocity of the cars sliding with friction. So that's what I'm going to do, is I'm needing to find VF over in this section to find my VI over in the green section. Now, collided means law of conservation of momentum. So that means I should think about this before the collision. Here's car A, which is going to be our 1500. Here's car B, which is going to be the 1250 car. And then after the collision, they're stuck together. So we already calculated that's 2750 stuck together. The momentum that occurs before, so mass A, velocity A for the momentum of car A, and mass B, velocity B for the momentum of car B, will be equal to the momentum after the collision, so the total mass multiplied by the total velocity. This should be pretty simple for us to solve now, I hope. 1500 times 20 plus 1250 times 0 should equal 2750 times our total velocity. That's just 0. Anything times 0 is 0, so that should be easy. We get here that this is going to be 30,000 is equal to 2,750 times the total velocity. Divide both sides by 2,750. 10.9 meters per second, and that is going to come over here to our green side, 10.9 meters per second. We now have 3 pieces of information. This is going to be enough for us to find our acceleration. I will use the VF squared is equal to VI squared plus 2 times A times D formula. I'm going to solve generally first. VF squared minus VI squared over 2D is how it solves generally. You can do that algebra on your own. And the acceleration here is going to be 0 squared minus 10.9 squared, all divided by 2 times 15. We're going to find here that our acceleration is a negative number, but that should make sense. It's slowing down a forward movement. And our acceleration turns out to be 3.96 meters per second squared. We can substitute this, finally, into our coefficient of friction. Now, coefficient of friction is a scalar. It does not have any directions, so do not include that negative sign. That negative sign is the direction. That's all it is. And we see our coefficient of friction is 0.40. That's it for today. It's just showcasing this type of problem again, insisting that you do your summary where you say what's happening and splitting it with the and then. And when you do that, you could begin trying to solve for what you need, the coefficient. And when we tried that, we saw, oh, I don't know my acceleration. That tells me what to do next. I should use kinematics to find my acceleration. I don't have enough information in my kinematics. Oh, I should go across the and then to find out information to help me solve for my kinematics. Hopefully, the way that I solved this showed you that every time I ran into something uncertain, that gave me a hint on what I needed to do next. All right, good luck with that, everyone. See you later.